Hello everyone. Here we are in the second part of the spectroscopy. So in the first part, we'll be discussing about the electromagnetic radiation and properties of the electromagnetic radiation and spectrum of the electromagnetic radiation. So today we are going to discuss the spectroscopy part 2. So in this, we are going to discuss about the types of the spectroscopy. Okay. So basically, the type of spectroscopy depends on the whether light interacting method means spectroscopy is nothing but it is the interaction of the light with the matter. It's so simple. Okay. So when the light is interacting, so whether the light is absorbed or emitted are scattered. These are the three processes that we discussed earlier during the interactions of the light. Okay, so when a light is incident on the surface of the matter or on a system, okay, there are three possibilities. The first possibility is light can reflect back. Okay, light can reflect back. Okay, so the second possibility is light can transmit through. Okay, light can transmit, and the third one is light can scatter. Okay, so these three processes we discussed in the earlier video. If you are not aware of these three processes in detail, just go with the earlier video. Okay, so today we are going to see the types based on the properties. Okay, based on the type of interaction. Okay, so if it is absorbed when a light falls on the system and the light is absorbed, then it is said to be absorption spectroscopy. Okay, absorption spectroscopy means the light got absorbed by the molecules of the material. Okay, absorbed by the molecules of the material. So what happens when the material is absorbed light? So there may be molecules. In that molecules, there may be electrons that may exist. Okay, or there may be bonds. Okay, that may vibrate, or the molecule itself can rotate. Okay, these are the three processes that we are seeing in the types radiation wavelength types. Okay, so when it is electronic absorption, it will be going to happen in UV radiation. That's why UV spectroscopy is considered to be electronic spectroscopy. Okay, so I am just repeating the earlier class. Okay, so it is electronic spectroscopy. Okay, when the energy that is not sufficient for the electronic excitation, there are some other process which requires less energy when compared to electronic excitation. They are said to be vibration and rotation. If it is vibration, it requires little higher energy than compared to rotation. So if it is vibrating the bonds, then it is said to be vibrational spectroscopy. Okay, vibrational spectroscopy. So vibrational spectroscopy can arise from the IR radiation, infrared radiation. Okay, if it is rotation, it is from microwave radiation. Okay, so the spectroscopy is called rotational spectroscopy. Okay, so by the absorption, only these three processes can happen. Okay, by the absorption, these three processes can happen. So these three are absorption spectroscopy. Okay, by the emission also there may be this process which may occur. Okay, if the emission is resulting into the vibrational or rotation, then it is said to be emission spectroscopy. Means when an electron turn back into its native place or native energy state, the energy will be released. This energy, okay, so this energy, if we record it, okay, it will be recorded in the spectrophotometer, which is the instrument that is going to record the that is going to study the light waves. So if we record the emission wave light, then it is said to be emission spectroscopy. If we record the absorption light, okay, then it is said to be absorption spectroscopy. Okay, then it comes about the scattering. Scattering is nothing but when a light beam is passing and if any small particles are there, they're going to scatter. Means they're going to reflect in not exactly 180 degrees. So they reflect with some angle. So it is like deviating the part of the light. Okay, which make the which makes the particles to glow or to scatter. Okay, so when the scattered light is observed, okay, when the scattered light is studied under spectrophotometer, then it is said to be scattering spectroscopy. Okay, so if the process of the light is absorption, then it is said to be absorption spectroscopy. If the process of the light is emission, that is said to be emission spectroscopy. If the process of the light is scattering, if we recording that light, then it is scattering spectroscopy. Okay, so these are the types of the spectroscopy based on the light interactions onto the system. Okay, next. So in detail about the absorption spectroscopy. So it is a scattering. Sorry, it is the absorption spectroscopy consists of the electromagnetic radiation to be absorbed by an atom and a molecule. If a molecule absorbing the energy and we are recording the spectroscopy, then it is molecular spectroscopy. Okay, so if it is in very detail, it is absorption molecular spectroscopy. If absorption happened by the atom, then it is absorption atomic spectroscopy. Okay, so both are can happen by the absorption. Okay, so in that if it is absorption happened by the atom, then it is atomic absorption spectroscopy or absorption atomic spectroscopy. Okay, so if it is molecular, it is molecular absorption spectroscopy or absorption molecular spectroscopy. Okay, so generally the excitation will happen. Okay, electronic excitation or bond excitation will be what will happen. Okay, from lower energy to the higher energy. Okay, so when when it is going to excite means when there is a match of the energy of the energy levels gap. Okay, if the gap between the energy levels is matching with the incident light energy, then only it is going to excite. Okay, if not, it cannot reach up to the next level, so it cannot excite. Okay, so that we will not consider. Okay, so when the energy gap between the energy levels is matching with the energy of the incident radiation, then only absorption can take place. Then only you can observe the spectroscopy. Okay, so this is about the absorption spectroscopy. So next, scattering spectroscopy. So it is measured from the scattered lights. Okay, so scattered light from the substances. Okay, so this scattering spectroscopy is generally named as Raman spectroscopy because light scattering is defined by the CV Raman. Okay, so it is said to be Raman spectroscopy. So what are the changes in the molecule that are going to occur in the Raman spectroscopy is it is also about the vibration. So IR spectroscopy and the Raman spectroscopy both are with vibrational spectroscopy only. Okay, both are absorption spectroscopy. If it is atomic level, it is atomic absorption spectroscopy. If it is molecular level, it is molecular absorption spectroscopy. Okay, so in vibrational spectroscopy, if it is IR, okay, So there are two specific rules which differ the IR and normal spectroscopy. Okay, so in detail we will be going to discuss that. But before that, you need to remember that in both of the systems or in both of the spectroscopy, we are using IR wavelength only. Okay, so infrared waves only. But the thing is, scattered light is studied under Raman spectroscopy, whereas observed light is studied in IR spectroscopy. Whether the scattering or observed light is resulting into the vibrations of the molecules. So both are vibrational spectroscopies only. Okay. So this is about the scattering spectroscopy or Raman spectroscopy. Okay. And emission spectroscopy. So when we measure the emitted radiation, okay, so when it is going to emit, when a higher energy electron releases or come down to its lower energy shell, then the energy gap or the extra energy what is losing will be emitted. Okay, so you can measure that emitted light and if it is the spectroscopy of the emitted light, then it is emission spectroscopy. Okay, so before the emission of light, it must absorb the energy. So it must excite. Okay, then it can release the energy. Okay, so emission can be induced by the sources of energy such as flame or electromagnetic radiation. Okay, so because based on the electromagnetic radiation and the flame, it can be altered. Okay, so the induced the light emitted light can be induced, means can be altered. Okay, so this is about the emission spectroscopy. So these are the types of the spectroscopy. So next we are going to see the principles of the spectroscopy. So the principles are first Lambert's law. So Lambert's law is indicating that it is about the chromatic light, means which is having one chroma means color. Okay, one color. So when it is about one color means one type of wavelength. Okay, so single wavelength having light. Okay, so for example, I have wavelength or UV wavelength or visible wavelength, whatever. When a monochromatic light with single wavelength light passes through the transparent medium. Okay, let's say I have taken the test tube and in that some compound is dissolved in water and here I am passing a ion wavelength through this medium. Okay, so intensity of transmitted light decreases with the thickness of the absorbing material. Okay, so if I take this test tube with more thickness, okay, so the light that can pass through this medium decreases. Okay, if I take a material that can have more thickness, if it is that is with more thickness, the amount of light that can transmit through this transparent material will decreases. Okay, in real life also you will observe this. Okay, so if not, you can experience by taking a thick glass and a thin glass. Okay, try to pass through. Okay, so this is Lambert's law, which is nothing but the intensity of the light that is passing through will be inversely proportional to the thickness of the material. Okay, so it is about the material, it is about the test tube. Okay, so glass. Next, Beer's law. So it says that the transmitted monochromatic light decreases exponentially with the concentration of the absorbing material or absorbing substance. So if I the same test tube Now the thickness is not altered. Now I am altering the concentration. Okay. So if I make a saturated sodium chloride solution, will it be able to see the other side through the test tube? No. If I take a very dilute sodium chloride solution, which is almost transparent like water, then there can be a visibility through the test tube. So what it is indicating, when the concentration of the absorbing solution, okay, or absorbing the substance, sodium chloride is going to absorb the light when it is present in the solution. So when I increase the concentration of the sodium chloride, or when I increase the concentration of the absorbing substance, then also it is going to decrease the concentration. So this law is what? It is inversely proportional. What is inversely? Intensity of light that can pass through a substance is inversely proportional to the concentration of the substance. Okay, concentration of the substance. Okay, so this is about the Lambert's and Beer's law. Lambert's law is about the test tube. Okay, so for your remembrance, I am giving this. Okay, so Lambert's law is about test tube. That is what material. And Beer's law is about the solution. That is what sodium chloride. Okay, next. So all together, so advanced lag is given, Beers-Lamberts lag. Okay. So what is giving? So it is a combination of Beers and Lamberts lag. Okay. So amount of light absorbed by a substance. Okay. So far intensity of the light was discussed. Okay. Now it is giving absorbed light. Okay. Light absorbed by the substance is nothing but this is what. So the transmitted decreases in the beads law because it is absorbed. Sodium chloride is absorbed. So if I increase the concentration of the sodium chloride, it is going to absorb more light. So that is what is given in the beads law and beads Lambert's law. So it is nothing but the concentration of the substance. Okay. So the concentration of the substance is directly proportional to the absorption light. Absorption of light. Okay, and path length if I increase. Okay, if I increase this length, or if I increase the width of the test tube, if it is this much, so it's going to touch many molecules, so that the absorption absorption will increase because more number of molecules is going to happen. Okay, so it is also proportional to the R length. Okay, so this is what Beers and Lambert's law. Okay, so based on this principle, we will be going to see different kinds of the spectroscopies. So in the next session of this video, spectroscopic series, so I will be going to take up the electronic, vibrational, and rotational spectroscopies in detail with their selection rules and applications and how to analyze some molecules based on the spectroscopy types. Okay, so if it is UV spectroscopy and it is given some wavelength values or some values based on that, how to identify the molecules, that we will go into. Okay, so please be follow the series. Okay, so if you want any live classes to be attended, so subscribe it. Okay, once you get subscribed for the channel, you will be going to get notified as soon as I start the